All right, I actually killed that recording instead of pausing it. So this is the next one. So when we talk about that sustained innovation, we're looking at that here. Okay, so if we take that sustained innovation and that line that's going up, this is what happens. We end up with an S curve on this. This is the path of tech. That's what we're looking at here. So the introduction of the technology, in other words, it's becoming relevant. It slopes up like this, right? So if we take the PC and we look at the personal computer and its flight upward, this would have been the 70s through the 80s, and then this would have been the 90s through the 2000s, and then this is us now. So basically, as the maturity of the technology get there, the bugs worked out, the performance increases, and the performance really increases. Again, if we're just talking about processors, we're looking at 4 megahertz processors, 7 megahertz processors, 8 megahertz processors. And then once you hit basically the 90s upwards, then you hit hundreds of megahertz and then thousands of megahertz and then multiple thousands of megahertz. And then this is where we're adding cores. Because as I've said before, yeah, you can add cores to it. And that helps a computer because there's a core free to do what you want. And also if you have a process or a program that needs to use multiple cores or can use multiple cores. For instance, if you're doing some kind of video rendering or animation or something that's heavily computer intensive, CPU intensive, then adding more of those CPUs, right? I can divide that out and have more getting done. But again, it's still like you're adding more lanes for traffic, which is a fantastic thing, but you're not increasing the speed of the traffic. So you're never going to get this back, right? You're never going to be able to say, let's add multiple processors and increase the speed by X amount. But if we take a look at where the new processors are at, this is ARM, ARAMR processors, which stands for RISC processing. So you can look up RISC-V or RISC-V. And I'll talk about that. I actually have that down below. So we'll talk about that in a minute. Then really this is where you start to see that actually came around in the 90s for desktop computers, but that got abandoned, so we'll leave that. Then it comes around again in these small devices, you know, like calculators, little PDAs, that kind of thing. And this would have been the 90s through the early 2000s. And then this would have been 2010 to us on, and we're in this slope here in this. We're increasing the performance, boom, 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 massively. And eventually it's going to get to the point where you can't increase performance as much. Well, once you hit this part, your bang for your buck is going way up. So in other words, Intel and their processors, they use CISC processing. It's taking them tons and tons of money to make any kind of incremental improvement, where when they first started, it took them much less money to make these massive jumps. So this is, I mean, don't blink, right? Because this information that I save for now, because of where we are with the processors and everything, I mean, you could apply this to storage and anything. The importance of this is the fact that this is something that you can look at, right? Again, I kind of wasn't even paying attention at the time. I was just like, well, it really is. We're not getting that processor power out of those CISC processors. I wonder what's going on over there at Intel. Are they just not doing it, or they hit a wall? And I wasn't even examining it or looking at that. And then all of a sudden we see this massive growth in the mobile processors that are RISC-based. And then I'm like, oh, should have saw that, should have realized that here we were in desktop processor land. And as that's leveling out, I should be going, something else is going to happen. Now, investors use this kind of stuff, right? This is how these investors get rich. They're trying to figure out where's this stuff at so they can invest in the next company that's coming out. This alone is a reason to invest in Apple. Apple is still undervalued because, right, with their processors, they're in this slope. So that should mean that their value as a company is going to continue to grow. All right, now I'm going to pull up the CISC versus RISC stuff. And we'll take a look at what are you talking about. All right, so I should have mentioned this. This was actually the next thing. This is an excellent example that I took from somebody else in their video. But here's 1940 as your disk drives and vacuum tubes, vacuum tube TVs, and boom, they're dead. Well, something else started during that time, right? So right about in the 70s, 80s, you got hard drives, transistors, CTRs, and TVs, and now you're at SSDs, flat screens, TVs. So you could do this across TVs, you could do it across storage devices, tons of different things you can apply this to. That was kind of the point in that. It's just to show you a little bit. All right, so let's let this load. Okay, so I see this as failing to see. So the first portion of this, I talk about, well, what is this RISC and what is this CISC? What is it and why was it used? Well, these are two types of technology to use in CPUs. There's different other ways to do this as well. And so everything that we use in our PCs is CISC. And so we'll take a look at what that means in just a minute. Those are also designated as x86 instruction set, which I explained in other classes. And in the current 64-bit Intel, i3s, i5s, i7s, which use an x64 instruction set. And again, I talked about instruction sets, so we won't talk about that. Here's the primary goal. The primary goal of CISC architecture, of how I'm going to put this CPU together, is to complete a task in as few lines of assembly as possible, right? So as a few lines of this as possible. And then I talk about, C and what that all equals. Okay, so RISC, it was originally, I won't say fully invented by them, but IBM did some research and they had been doing processing for a long time by the time that you hit the 80s. And they showed that 80% of the processor time was spent on 20% of the smallest instructions. So that means you're spending 80% of your time on small instruction sets, not big ones, just small ones. 80% of your time cranking through these little tiny things instead of using the big ones. Well, CISC, again, what is it supposed to be doing? Well, it's complex instruction. Its goal is make this big complex thing, shove it through as fast as possible, right? But IBM, of course, in their research is like, that's not the way it's working. How it's actually working is that 80% of the processor time is just spent on these tiny instructions. So RISC is based on simplicity over complexity. Now, why CISC was really chosen in the beginning, why did Intel choose it, and why was it used heavily, is because RAM is expensive, and RISC uses more RAM. And so back in the day, when you wanted to buy a computer, and you're going to go out and buy yourself an IBM PC, that RAM was like, well, back then, sometimes half the cost of the computer you're putting together. It was expensive. So if you had a processor that used less RAM, then that would be a good thing, right? I can do the same thing that you want me to do with this processor that uses less RAM, and I don't have to spend all the money on the RAM. So there was a reason for that. So right here, let me go up to here. Okay, so reduced instruction set computing processors use simple instructions that can be executed within one clock cycle whenever possible. As a result, several instructions must be executed to build one command. So again, it's not complex, it's little tiny things. Sounds slower, but it isn't, due to the fact that each instruction only is requiring one clock cycle to execute. So again, if it's a complex instruction, you're not computing that in one clock cycle. You're going boom, 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 boom. Now it's done. A clock cycle is where you get your gigahertz rating or your megahertz rating. How many millions of times can it process something in a second? That's where that's coming from. So that's your gigahertz rating. So RISC effectively provides more computing power at a lower gigahertz. So what we're trying to piece together here is that IBM found that 80% of the time you're doing small things. And so RISC is basically designed for those small things. That means 80% of the time you can get those small things done in a clock cycle using less power, using the processing power more efficiently, because the more complex stuff, right, it's going to take more cycles to get those complex things done. It was really, really cool. I broke, let's just look at this and then I'll tell you this other story. So basically here's CISC. It emphasizes hardware. Risk emphasizes software. How are you putting it together, right? You want small chunks. That's what you want your executions to be. This CISC, as a matter of fact, Intel has become faster and faster because what they do is they look at what people are doing. So you're playing a lot of video, and back in the Pentium 4 days, they included a bunch of code straight into the processor for video decoding. That way the processor was faster, and it was, you know, like a Pentium 4 was a little ahead of its time. By the time people used it, they were already on the Core 2s and stuff like that. But still, if you were doing a lot of video decoding, like watching videos on YouTube, that's what I'm saying, that Pentium 4 was 40% faster than the previous CPUs, because what they did was they put the stuff in the hardware. They put the all that complexity in the hardware. That's the only way they could make it faster. Where in RISC, you can make it faster just by writing your software correctly. All right, so multiple instruction sizes and formats, so tiny ones and big ones. Instructions of the same set with fewer formats. So let's make that less complex. This uses less registers. This uses more, and you can look up what a register is. This uses more addressing modes, and this uses fewer. And this uses extensive use of microprogramming. And this RISC uses a complexity that's in your compiler, in your software. So you're still really kind of comparing complex hardware to complex software, basically. Instructions may take a varying amount of cycle time. Instructions take 1 cycle in this one. Pipelining, because of this, is difficult. Now, pipelining is a process, and you can look up a lot of information on this, of the processor understanding that the data coming in is a certain type, and it can divide this into different pipelines so that when it gets to the processor to actually be computed, to be figured out, it's got several pipelines of this data moving in. And so because of the fact that you can have different sizes and take varying amounts of time, putting things in the pipeline to be processed is more difficult. Where in this one, because you're processing the same kind of cycle, you can just put them in the pipeline and it'll figure it out, right? So in the late 80s and 90s, CISC made it and RISC didn't. However, there was a few RISC makers, MIPS, SPARC, IBM Power CPUs. The IBM Power CPUs is what Apple used until they switched to Intel CISC in 2005. And that was due to a lack of CPU availability. So IBM was really basically like, hey, Apple, it's kind of nice you want those CPUs, but whatever, right? So they could never get what they wanted. They'd get these people ordering Apple computers. And my friend worked for them at the time, and it was a very big frustration. They'd have more orders than they could fill because they didn't have processors to put in the computer. Thanks, IBM. So they switched to Intel, which was going to always provide them processors. They wouldn't have a problem with that. All right, so to illustrate the diversity of the time back in the 80s and 90s, Microsoft programmed their Windows NT, which is what our current Windows 10 is based off of, the predecessor to XP, to work on CISC and RISC. So there was a version of Windows that would run on either one of these pieces of hardware, whichever you decided to use. Then, as I said, once the PC starts to try to go mobile, like people want some of this in their pocket, the Newton OS used ARM, and that stood for Acorn RISC machines, and that was a RISC-based processor. And 1997, the Palm came out, and that was a hugely popular device. And then ARM started to be put into a lot of different things. ARM now they deal with the design, and there's a certain portion of it actually goes back to Cambridge University because that's where they did their research over in England. And so in any case, basically now there's ARM and there's different versions of ARM, and they'll just write up the specs according to what people are desiring and wanting, getting their feed into this, and then going, okay, so here's the new processor design. And then Samsung and everybody will start, using that to make their processors. Anyway, that's ARM Holdings now. Anyway, they license it to other with 95% of the mobile market and 100% of the graphics market, basically. Now, graphics is a bit different, so they combine different kinds of computing. RISC computing is huge. Okay, so that's kind of the point. CISC computing, that's your desktop PC. RISC computing, that's all your mobile devices and most of your graphics. So Apple originally based their stuff off of that. They do their own custom thing now, but Qualcomm, Samsung, Texas Instruments, NVIDIA, even IBM, tons and tons of stuff. All right, so what are we really getting to here? Here's the sad stuff right here. In 2006, the iPhone was released and mobile computing was changed forever. As a matter of fact, after the iPhone success, Apple was hoping Intel had a chip they could use. So they released the first iPhone and they're like, gosh dang, this processor barely cuts it, right? It barely does what it needs to do. And they're working with somebody on that, right? They're not making their own. And so they're like, hey, Intel, you got a processor we can use in these phones that we're doing? Now think about it. Think about what's happening here. Intel was selling StrongArm that they had bought. So somebody at Intel realized, and actually I think it was the CEO prior to the one that came after, which is prior to, anyway, doesn't matter. They had bought in this company called StrongArm. Basically, it was a chip design, not facility, but brain power, brain trust, and they were going to do something with it. And then they just decided, no, we don't want to do something with that. So Intel basically is selling off StrongArm, which they could have used in the Apple iPhone, and they told Apple, we don't have any interest in mobile. We're not going to go there. So in 2010, the iPad was released, and the future of mobile computing was solidified. Millions of iPhones, iPads, Android devices have been sold and continue to be sold. The popularity of these devices eclipse what PC sales are. What is the point, McBride? Well, the point is RISC is the dominant processing architecture, not CISC. So we still stick our mind into this PC mode and go, well, it's not really a computer unless it's running Windows, right? And of course, we know that that's not true. So you have tons and tons more RISC processors out there running in the world because they're running in all these mobile things than you do CISC. This portion is what I've already discussed with our S-curves and so on, and the fact that we're not getting out of CISC what we used to. It's not happening. Now, here's the big thing. This is what I'm working on too. Where does this leave Microsoft? Microsoft has bound itself to CISC, aka Intel. They bound themselves to Intel. And it's almost like they're going to go down with the ship. Hopefully they're going to switch soon. But back when the iPad came out, right, they immediately, like within a year, 18 months, 2 years, they released their tablets that were Microsoft tablets. One of them was called a Surface RT. RT basically was a RISC processor. It was an ARM-based processor. They made Office work on it, but pretty much nothing else worked on it that worked on your regular Windows machine because it's a different processor. You have to recode it. Now, instead of sticking with that, that's the bad thing. So instead of sticking with that and saying, we're going to keep using that, they listened to all of the bloggers and they looked at their sales, and everybody was going for the higher ones, right? So they're all buying the Intel ones because it'll run anything that Windows can run. That makes sense, right? But if you're watching this, right? If you're watching this and you can see that Intel is not providing the processing power that it should be able to provide, then you should be hedging your bets, right? You're a big company, you got millions and billions of dollars. Why not keep that RT running, right? Why not go to programmers and say, hey, why don't you program this for us? We'll give you a little spiff on this. We'll really advertise it for you. We'll push it. They didn't. They just dumped it. So then, of course, years later, they have their whole Windows 8 debacle that happens. And then they start telling everybody, we are going to run Windows across anything. You can run it on an ARM, you can run it on a CISC, right? But they don't word it that way because that's techie verbiage, right? They say you can run it on your phone, you'll be able to run it on your tablet, you'll be able to run it on your PC, you can run it on anything. And so they started to work on Windows 10 running on anything. so 2010, they're way down the road here, right? 2002 was the time that they came out with their tablet edition. It's just frustrating. And so right after 2010, when the iPads released, Microsoft brought out RT, and that's right here, RT. And they have some problems. I should mention this. So another problem with CISC versus RISC is the power it takes to run a CISC processor. So CISC just takes more power. It was never designed to be efficient in computing. Oh, and I was going to tell you that when they were first developing the RISC, they wanted a really low power processor, something that could compute without really using too much battery power. And they found the thing computed on less power than they could actually measure at the time. And they're like, wow. Of course, back then, right, you're talking about these things aren't that big of a deal. They don't have that much processing power, but look at where it's come, right? That S curve and then ramping up. So Microsoft does RT, then they dump it, and they start relying on Intel's Atom processors, which were low power, but the price of Intel is more expensive. The power efficiency is bad. And then how fast can the CPUs process at the lower power consumption was poor. And so this is what you kind of end up with as of January 2019. If you wanted a Surface Line, they're between $800 to $2,100. Now they have dropped that down to $500, but you really don't want one of those. Apple's iPads begin at $429, and really they're down to $3 something now, $370 or something like that. And they go up to now $2,000 or whatever. So why would I want to get a Microsoft tablet? It's not going to run as long. It's not going to have better processing power. And it's going to be more expensive for me to do. The comparison is not good for them. Now, these are all things that they can see. This is what they know already. If they had kept their Windows RT, right, and they had been looking at these strategies and looking at the fact that, oh, that CISC processor is bending the curve here up here. Intel keeps promising stuff, but we're not getting it. We better make our OS to run on ARM, so to run on anything. And then people can take Windows 10 and they can put it on a phone if they want to, or they could put it in a tablet as long as we don't care. Let them put it in whatever they want. It'll run on what they want to use. Then they'll get the benefits of battery power. They'll get the benefits of processing power, and they'll get the inexpensiveness of it because Intel is really expensive. They didn't hedge their bets on that. And still at this point, they are now saying, yeah, we're making that. We're in the process. We're doing it, but they haven't fully implemented it. And so you have this whole Chromebook thing, right? And Google lies. They all lie when they do this kind of advertisement. Oh, you don't get viruses and you don't do this and that. They really push their Chromebooks. But right now, what other thing can you do if you don't want to use Apple? If you don't want an iPad, then you got to get an Android or you got to get a Chromebook. That's what you have to do, because Microsoft's is really expensive stuff. And anything that's running Windows 10 is going to drain your battery power, and everybody knows it. And that's the problem. If they can get that stuff over to ARM, which they should have done 10 years ago, right? They should have been in that process already. Then all these makers, HP, Lenovo, all of them would have these totally compatible with anything you want to run systems, but they're using ARM. So you get all the benefits of the power and the low power consumption. So Microsoft is in trouble. And the reason they're in trouble is because they wouldn't look at reality of what's staring them in the face. And they haven't been looking at reality in a lot of ways, right? I've talked a lot about that. But this is the biggest one that's going to hurt them if they don't get this stuff switched over and off of Intel. I don't mean off of it, but provide it for both. They're really in trouble. And I think Apple moving off of Intel themselves is going to, of course, you're going to get a lot of stuff about how much faster these Apple Mac computers are not running Intel. And then Microsoft's going to go, boom, we got to do this, right? Because HP's got some incredible processors that are just kind of sitting there waiting to be used. Everything is moving to RISC. CISC is dying, and Microsoft does risk doing what a lot of companies did back in the 80s, and that's die themselves because they've tied themselves to a company that won't move forward, that won't shift. I'm sure Intel within a year could produce an ARM processor that would rival everything out there made. They've got the ability, but they haven't done it. So anyway, that's kind of the takeaway, is that you have to know what's going on in this tech world. And I use these massive examples again, but see, if you're one of those people that's all running around, it's all about the PC, it's all about the PC. You do that too long and you're going to find yourself having to learn real quick. And of course, the people that rely on you will go, you're kind of stupid, right? Because you didn't see any of this, right? So anyway, if you have any questions, let me know. Get with me.